Today we'll be talking about the four-way handshake. This is a process by which a source key material is turned into data encryption material that will encrypt actual data frames. WPA authentication begins when a user associates with an access point. The access point blocks access to the authentication server until it is authenticated. The user provides credentials which are communicated to the authentication server. The authentication process is enabled by the IEE 802.11 framework. Mutual authentication helps to ensure that only authorized users access the network and confirm that the client is authenticating to the authorized server. It helps protect users from accidentally connecting to unauthorized rogue access points. A four-way handshake takes place between the client and the access point.
Now we are going in depth about the four-way handshake. It begins with the client and access point having calculated pairwise master keys. A pairwise master key, or PMK, is a shared secret key generated after both the client and the access point have been authenticated. Once the access point has transmitted its anons to the client will then receive it and calculate their PTK. Anons is an authenticator number used once, and a PTK is a pairwise transit key. The PTK is generated by putting together the following attributes: PMK, ANUNS, SNUNS, access point MAC address, and a client MAC address. The product is then put through a random function that generates completely random encryption schemes.
The client responds to the ANONS by sending the access point its SNONS plus MIC. SNONS is the client number used once, and it is protected with the MIC, which is a message integrity code. Now the access point has received this SNONS with protection and can calculate the pairwise transient key, and can validate the message integrity code to make sure it wasn't harmed in transit. The access point will then send a group temporal key, or GTK, in this message to a client, and it will also protect the frame with a message integrity code. The client will then receive and install the GTK, and then the client will now respond by telling the access point that both the frames we are good to go and they are ready for encrypted data traffic.
TKIP and the related WPA standard implement three new security features to address security problems encountered in the WEP protected networks. First, TKIP implements a key mixing function that combines the secret root key with the initialization vector before passing it to the RC4 initialization. WEP, in comparison, merely attached the initialization vector to the root key and passed this value to the RC4 routine. This permitted the vast majority of the RC4-based WEP-related key attacks. Second, WPA implements a sequence counter to protect against replay attacks. Packets received out of order will be rejected by the access point. Finally, TKIP implements a 64-bit message integrity check, or MIC.